Hello everyone. Today we will be going to discuss main properties of inhaled anesthetics. Okay, just main properties. Now let's assume this is a blood vessel and this is a tissue, okay, or a cell. Now the solubility of anesthetic in the blood, okay, the solubility of the anesthetic in the blood will determine the rate of induction of its action. Okay, see, if the drug is more soluble in the blood, okay, then it will remain in the blood. It will not go quickly into the cell. Okay, so the onset of action of that anesthetic will be slow. And if it is less soluble in the blood, then it will quickly go into the cell. Okay, it will leave the blood vessel and the onset of action will be fast. So if there is increased blood solubility, okay, then the onset of action will be slow. And if there is decreased blood solubility, okay, then the onset of action will be fast. Okay, now the solubility of inhaled anesthetic in lipid determines the potency. Okay, what do I mean by that? See, potency means either the anesthetic is strong or the anesthetic is mild, is determined by its solubility in the lipid. If the anesthetic is more lipid soluble, okay, then it will quickly cross the cell membranes. Okay, it will quickly cross the cell membranes because the cell membrane contains lipid. So if it is lipid soluble, it will quickly cross the cell membranes and it will enter the cell and produce its effect. So if it is lipid soluble, highly lipid soluble, okay, then it will be a very strong anesthetic. Okay, and if it is less lipid soluble, then it will be a mild one. That's what we mean by potency. Now potency is inversely proportional to minimal alveolar concentration. So what is minimal alveolar concentration? See, it is the concentration of anesthetic in alveoli that is required to, means, see, it is the concentration of anesthetic which is required to produce its effect in 50% of patient. Okay, 50% of patient will not respond to any painful stimulus. That is what we say minimal alveolar concentration. And why is it inversely proportional to potency? See, if let's say minimal alveolar concentration of one drug is 3 milligram, okay, obviously this is a fake unit, just for your understanding purpose. That is, let's say it is drug A, okay, drug A. Now drug A produce its effect in 50% of patient at a concentration of 3 milligram. Now let's say another drug is drug B. If the drug B wants to produce its effect in 50% of patient, it requires, let's say, concentration of 20 milligram. Okay, so which drug is more potent? I think drug A is more potent. Even with a very small concentration, it is producing the same effect. Okay, that's why drug A is more potent. That's why we say that if the drug has less MAC, minimal alveolar concentration, then the potency will be high. And if the drug has high MAC, then the potency will be low. That's why both are inversely proportional to each other. Now, next main property is arteriovenous concentration gradient. And what is arteriovenous concentration gradient? See, arteriovenous concentration gradient is difference between concentration of anesthetic drug in artery and vein. Okay, so let's try to understand. See, this orange part here is artery, the green one here is capillary, this is vein, and this is tissue. Okay, let's say the concentration of the anesthetic in the arterial side is 100 milligram. Again the fake units. okay, but doesn't matter, it's just for understanding. See, it's 100 milligram. Okay, now when it enters the capillary, it will be taken up by the tissue. Okay, now let's say after the tissue is taking up the anesthetic from the artery or the capillary, let's say 20 milligram is left in the vein. Okay, so what will be the arteriovenous concentration gradient here? It will be 100 minus 20, that is 80. Okay, now let's say this is drug A again. Okay, now in another drug, let's say this concentration of the drug in the artery is 100 milligram. Let's say it is drug B. Okay, now again the drug will be taken up by the peripheral tissue. These are peripheral tissue. Okay, peripheral tissue. See, if it will be taken up by the peripheral tissue. Now when we measure the concentration of drug B in the vein, let's say it is 80. What does it mean? It means that peripheral tissue is not taking too much drug from the capillary. In first case, the peripheral tissue was taking a lot of drug. That's why in venous side its concentration was low. Here let's say the concentration remains 80. So what will be the arteriovenous concentration gradient here? It will be 100 minus 80 is equal to 20. So in drug A, the arteriovenous concentration gradient is high, while for drug B it is low. So what does this mean? Okay, what should we derive from this? Let's try to understand. See, in this case, the concentration of the drug in blood remains low, while in second case the drug remain confined to the blood vessels. See, it is not entering the peripheral tissue very quickly. So here the concentration is high. It means in this case the blood will not saturate quickly. Okay, the blood saturation will be less in this case, because the drug is not remaining in the blood vessel, it is entering the peripheral tissue. In the second case, what will happen? The blood saturation will occur very quickly. Okay, rapidly. Now the main confusing point for all the student is that in this case, drug A, the onset of action will be slow onset of action. Okay, and in this second case the onset of action will be fast onset of action. That is, the action will occur very quickly. Why is it so? See, try to understand one thing. In this case, the drug, a lot of drug is entering peripheral tissue. See, a lot of drug is entering the peripheral tissue. That's why less drug is available for the brain. That's the main deal. See, again, a lot of drug is entering the fat and other peripheral tissue in our body. So very less drug is available for the brain. That's why the onset of action is slow. Okay, and in this case, see, the peripheral tissue are not taking up a lot of anesthetic from the blood. That's why more drug is reaching the brain. Okay, and more drug is reaching the brain, so that's why the onset of action is quick in this case. So that's the main thing that you should understand, that why in drug A it's slow onset of action and why here it is fast onset of action. Now also see, here the just a second, sorry, here in this case the saturation is less. Okay, it means the blood is having less drug, so that's why brain will get less drug, and again the onset of action will be slow. And in second case it is exactly opposite. Now let's discuss about the third property. See, third property is blood gas coefficient. Okay, What does it simply mean? See, if the blood gas coefficient is higher, it means the drug is more soluble in blood. Okay, if the blood gas coefficient is low, it means the drug is less soluble in the blood. So if there is increased blood gas coefficient, it means there is high solubility in the blood. Okay, and as we discussed that if the drug is very highly soluble in the blood, okay, then the onset of action will be slow. So if there is increased blood gas coefficient, there will be high solubility in the blood and the onset of action will be slow. So that's the main thing. Now another point to remember is that if the blood gas coefficient is higher, okay, that is if the drug is more soluble in the blood, the partial pressure will rise slowly. Again, this is another confusing thing for everyone. So let's try to take an example and try to understand by it. The example is not exactly the same analogy, but it will help you to remember for the examination. Okay, let's say there is a tank, okay, a tank which is filled with water, and there is another tank which is also filled with water. Let's say both the tanks are closed. Now let's add sugar in first tank. Okay, what will happen? The sugar will simply get dissolved in the water. Okay, it is not going to affect any kind of pressure in this tank. It will just get dissolved in the water. Now in the second case, second tank, let's say we are adding stone. What will happen if we add the same amount of stone as the sugar? Let's say we are adding stones here. Okay, what will happen? The water level will rise, okay, and obviously the pressure in the tank will increase. So what do I mean by that? See, if the anesthetic is soluble in the blood, okay, the pressure will not rise, means it will not rise very quickly. Okay, while if it is insoluble in the blood, okay, then the pressure will increase very rapidly. See, you can remember it by sugar and stone example. So see, if it is insoluble in the blood, then the blood gas coefficient will be low, and if there is less blood gas coefficient, then the pressure will rise quickly. But if it is soluble in the blood, then the blood gas coefficient will be higher and the pressure will not rise very quickly. See, the rise of pressure is slow. So that is the main thing that you need to know for blood gas coefficient and arteriovenous concentration gradient. Now I have summarized all of these things in the end. Okay, see, remember all these things. Blood solubility mainly affects the rate of induction. Okay, it mainly affects rate of induction. Lipid solubility mainly affects potency. AV gradient mainly affects rate of induction. Partial pressure mainly affects potency. Okay, this we didn't discuss, so I am underlining it. And blood gas coefficient mainly affects rate of induction, because the solubility of the drug in the blood determines the how quickly the blood will work. So in case if you don't have time to go through all the lecture, or means you don't have time to read everything, then just remember these 5 points. Okay, that will be very, very helpful for the examination.